Hi, Science 30s. Mr. Riley here. We're looking at the last of all of our functional groups for our organic chemistry section here. The one we're looking at now is called esters. And now esters is a little bit different than the other functional groups that we've looked at. Esters are formed actually by a reaction between the last two functional groups that we looked at. So a reaction between a carboxylic acid and an alcohol will result in an ester. So if we look at this structure right here, this is what a basic structure of an ester would look like. We would have the R here represents a carbon chain. So we would have a carboxylic acid side of the molecule with double bonded oxygen, and that's how we can recognize which side of the ester is the acid side. And then we have another carbon chain with just the oxygen there. That's going to be the alcohol side. And we can always recognize an ester by seeing two carbon chains, and there's an oxygen in the middle of those two chains separating them. And on one of the sides of those chains, we're going to have that double bonded oxygen, and that's going to be our acid side of our molecule. Now, when we're naming these esters, we're going to actually use the names of the alcohol and the acid that produced the ester. So in order to name these, we're going to use the name of the alcohol first. And so the name of the alcohol, we're going to change the ending to YL. So it becomes ul group. So let's say my alcohol was methanol. The first part of our name would be methyl, so methyl. And then let's say our carboxylic acid was methanoic acid. So instead of methanoic acid, and this actually represents the conjugate base of that carboxylic acid, we would call this meth and O8. So the name of the ester that results from methanol and methanoic acid would be methyl methanoate. Okay. Now the uses for esters, there's tons of them. Synthetic fibers like polyester would be an ester. Fat molecules, lipid molecules are esters. Esters are really good at producing strong odors, and we're going to see that with our lab activity. So odors for cologne, perfumes, and things like that. There's many other uses. Esters are used as additives in a whole bunch of things, from fuels to fertilizers, and the list goes on and on. What we need to look at here is the actual reaction that produces esters. And so this has a couple different names. One of those names is an esterification reaction. And the type of reaction that is something that's called dehydrolysis synthesis. So we think about this name a little bit. Dehydrolysis, so we are going to be subtracting water. So we're going to be dehydrating these molecules. And synthesis, we're making something new. So we're taking away water to make something new. And I'm going to show you how that works. So here I have an alcohol and a carboxylic acid. We can recognize the alcohol by looking at this group. We remember that's the hydroxyl group. And then we have the parent chain is 3 carbons. So we can name this alcohol. This alcohol is 3 carbons for prop, and it's an alcohol. So this alcohol is called propanol. Okay, we're going to use that later. This carboxylic acid, if we look at the parent chain, how many carbons are part of this parent chain? 1, 2, 3, 4. That makes it a butane chain with the carboxylic acid, the COOH group on the end here. And that makes it butanoic for 4 carbons acid. Okay, so we have propanol reacting with butanoic acid. Now, when this reaction happens, we're going to think back to that dehydrolysis. We're going to actually be combining these to produce water and something else. And how we're going to do that is we're actually going to take But we notice here we have a bunch of O's and H's in these two groups on the end here. And there's a reason why I drew these so that the functional groups are facing each other, just so we can visualize a little bit closer to see what's happening here. So, I mean, what's going to happen here is we have this right here is H2O. Okay, so this carboxylic acid is going to be losing a hydrogen, just like acids do. And this hydroxyl group over here, these two are going to be combining to form water. Okay, so that's going to be our first product here. So we're going to actually end up with HOH. And actually, I'm going to color code this because I want to make it fancy. So we're going to take HO, and then we're also going to have another H in here, HOH, to show that we combine those. We got that from the alcohol, part of it from the alcohol, part of it from the carboxylic acid. Okay, now my other product, this is going to be a little bit tougher here, is we're going to have to combine these two molecules. So I'm going to do just that. So we're going to take our 3 carbons here. Now, some of you guys maybe noticed, where are my hydrogens? Sometimes in organic chemistry, we get tired of writing all the hydrogens in. So we just, any bond that has nothing at the end of it, we assume it's a hydrogen at the end of it. So I'm going to take my 3 carbons, okay, and all my hydrogens here, okay, and then what's going to happen here is I notice all of this water, all this part right here is all gone. So this carbon has a bonding site that's ready to make a bond, and this oxygen has a bonding site that's ready to make a bond, and they're going to do just that. So I'm going to actually grab onto this oxygen, and I'm going to just continue on with drawing the rest of that butanoic acid molecule. Make sure I have all my 4 carbons. Fill in all my 4 bonds around all my carbons. And then I'm done. Okay, so there is my ester molecule. And remember, you can recognize an ester by seeing 2 carbon chains with an oxygen in the middle. One of those sides is going to have a double bonded oxygen on it. That is the carboxylic acid side. Now, to name this, we always name with alcohol first. Alcohol comes first. Remember that, kids. So the alcohol is propanol. So just like we said up top, this is going to leave us with what we call propyl. And then our carboxylic acid side of this ester is butanoic acid. And so that's going to leave us with butane. And we're changing the ending this time to O8. And so the name for this ester is propyl butanoate. Okay, so that finishes off all of our lessons on functional groups. There is a lab. There's a short quiz, and then there's also a lab assignment and sort of a lab quiz that you guys need to complete. You want to use your notes, these videos, the information from the lab. There's a video that goes along with the lab. You're going to need to use all of those things in order to complete the lab. And I wish you guys good luck. Please let me know if you have any questions. Talk to you soon.